Hi friends, welcome back to my YouTube channel. In this video, we'll be discussing about the multi-collinearity analysis. Suppose we are modeling a target variable say y using some input variable say x1, x2, etc. xn. Now our aim is to express this y in terms of these variables. We will choose these variables according to the relevance or influence to the target variable. For example, in modeling groundwater, soil moisture, rainfall, and temperature are the input variables. Now, these chosen variables might be so much interrelated that the model will be an overfit. That's why we always say y as dependent variable and all the xi's as the independent variable. The multicollinearity is a measure of this non-independency of the variables considered. And this will help us to explain whether the predictors are closely interrelated or not. The results are considered to be the best when multicollinearity does not exist within the datasets. The two commonly used indices to assess the multicollinearity are variance inflation factor or VIF for short and tolerance, which is shortened as TOL. The formulas are VIF is equal to 1 divided by TOL, where TOL is equal to 1 minus RB square. Now, this RB square is the coefficient of determination of the regression between the factors on the remaining other factors. The dataset is said to possess multicollinearity if this tolerance value is less than 0.1 and this VIF, that is the variance inflation factor, is greater than 10. In such case, the variable should be eliminated and should not be considered for modeling. Now let us write a code to find out this VIF and TOL using Matlab. So first step is to create a matrix of the input variables. Here I have a matrix MAT of input variables. So here I have 5 variables and 24 data points or time series points we can say. And then first we need to calculate the correlation matrix. So CORR, COEF of this matrix will calculate the correlation matrix. Now the second step is to find the inverse of this correlation matrix. Then find the diagonal of this inverse correlation matrix and then transpose. This will give the VIF. That is, first we will find the correlation matrix. That is CORR, COEF of the matrix of the input variables. Then we will find the inverse of this correlation matrix. Then diagonal elements of the inverse of the correlation matrix. Then transpose of this diagonal elements. So let us run the code one by one. So this is the correlation matrix. Now, inverse of the correlation matrix. So this is the inverse of the correlation matrix. Diagonal elements of the correlation matrix. VIF will be transposed of that. So this is the VIF of the first variable. This is the VIF of the second, VIF of the third, fourth, and fifth. Now the tolerance is 1 divided by the variance inflation factor. So this is the tolerance of each of the variables. Now in the VIF, you can see the first variable has the VIF of 13, which is strictly greater than 10. So these variables should not be considered in the modeling. That is, it has some interdependency or interrelated with respect to other variables. Okay, so thank you for watching and happy research.